Greetings to the respected faculty. I am Lasya Mandapati from CSC AI&ML D section. My roll number is 24951A6686. And today I'm going to present my project titled University Department Homepage, developed as part of the course Web System Engineering. This project focuses on designing and implementing a realistic production style website homepage for a university department. Now, when we think of a department website, we often assume that it's just a simple page with some information. But in reality, it's much more than that. It acts as a central communication hub that connects students, faculty, and even external visitors. So, the goal of this project was not just to create a visually appealing website, but to design something that is structured, scalable, and aligned with the real world web engineering practices. Throughout this presentation, I'll walk you through how this system was designed, what technologies were used, and what key engineering principles were applied. Before diving into the technical details, let me briefly walk you through how this presentation is structured. We'll begin with the abstract, which gives you an overview of the project and its purpose. Then, we move into the project objectives and scope, where I explain what exactly I aim to build and what limitations are kept in mind. After that, we look at requirements analysis, which is a very important phase in any engineering project. This includes both functional and non-functional requirements. Next, we'll discuss user roles and use cases because understanding the end user is critical when designing any system. Then we move into the architecture and technology stack, followed by the design phase, including wireframes and layout decisions. After that, I'll explain the front end and back end implementation, followed by sections on responsiveness, accessibility, and security. Finally, we look at testing, deployment, results, and conclude with key learnings. Now, the core idea behind this project is to build a production style university department homepage that reflects real world web engineering principles. Instead of treating this as just a static web page, the project focuses on applying concepts like separation of concerns, modular design, and maintainability. This means that different parts of the website, such as layout, styling, and logics, are handled separately, making the system easier to manage and scale. The homepage itself is designed to act as a central hub. It provides structured access to important information like academic programs, course details, faculty profiles, research work, and departmental announcements. Another important aspect is the use of modern web practices such as semantic HTML, responsive design, and accessibility standards. So, overall, the project is not just about building a web page, but also about creating a realistic, deployable web solution that could actually be used by a department. The main objective of this project was to design a homepage that is not only functional but also responsive, accessible, and easy to maintain. One key focus was reusability. So instead of designing everything from scratch from each page, the idea was to build modular components such as headers, footers, and content cards that can be reused across the site. This approach is very similar to what modern frameworks like React or Angular follow. Now, coming to the scope of the project, it is primarily a static site based system. This means that most of the functionality is handled on the front end with only optional backend support for features like contact forms or simple admin interactions. The goal was not to build a complex CMS, but to focus on structure, usability, and clean design. This makes the project both practical and aligned with real world requirements. In any engineering project, requirement analysis is one of the most critical steps because it defines what systems could actually do. Here, the requirements are divided into functional and non functional categories. Functional requirements include creating core pages like home, about, programs, faculty, and contact, ensuring smooth navigation between these pages. These define the actual features of the system. On the other hand, non functional requirements focus on how the system performs. These include fast loading speed, SEO friendly structure, compatibility across different browsers, and mobile responsiveness. Another important aspect is user centric design. This means the content should be easy to read, navigation should be intuitive, and users should be able to find information quickly without confusion. So, overall, this phase ensures that the system is both functional and user friendly. The system is designed for three main users: students. Students mainly use this design or system for accessing course details and downloading material. Next, faculty. Faculty use the system to update profiles and manage announcements, whereas finally the visitors explore programs and understand different department offerings. From this, we can see that each role has different needs, so the design ensures easy and intuitive access for all users. The architecture of this project follows a static site design pattern. This means that all pages share a common structure, including header, navigation bar, and footer. This ensures consistency across the entire website. For the front end, technologies used include HTML5 for structure, CSS3 for styling, and JavaScript for interactivity. The layout is built using modern techniques like Flexbox and Grid. An optional backend can be added using technologies like Node.js, Flask, or PHP. This backend can handle tasks like form submission, basic data processing, and overall, this architecture is simple, efficient, and scalable. The design starts with wireframes. The layout includes a hero section, navigation bar, program highlights, faculty grid, as well as a news section. This design follows a mobile first approach, ensuring usability across multiple user devices. Reusable components like cards make the design consistent and easy to update. The front end implementation focuses on writing clean, structured, and maintainable code. HTML5 is used with semantic tags like header, nav, section, footer, etc. This improves both accessibility and SEO, whereas CSS is used to define layout, colors, and typography. Modern techniques like Flexbox and Grip help in creating responsive layouts as well. JavaScript is used only when necessary for features like menu toggling, interactive elements, etc. One key principle followed here is to keep JavaScript lightweight and modular, avoiding unnecessary complexity. Backend components are optional in this project. If included, they can handle form submissions, basic data processing, etc. Technologies like Node.js, Flask, or PHP can be used here. The focus is not on heavy backend logic, but understanding data flow and request handling. Now, this slide includes example web pages like the McGill University and Santa Clara University, which have been used as references for this project. A modern website must be both responsive and accessible. Responsiveness ensures that the website works well on mobile phones, tablets, and desktops. This is achieved using media queries, flexible layouts, and more. Accessibility ensures that the website can be used by people with different abilities. This includes proper heading structure, keyword navigation, readable contrast, and so much more. These practices improve overall usability and make the website more inclusive. Security is an important part of web engineering. On the front end, avoiding inline scripts and using HTTPS and handling data carefully give it a huge boost. And on the back end, validating user input, preventing XSS attacks, and in addition, other good engineering practices include using version control like Git and maintaining a clean project structure. These practices ensure that the system is secure maintainable, and scalable. Now, testing ensures that the website works correctly. This includes cross browser testing, device testing, and checking for errors, whereas validation tools ensure clean code and accessibility compliance. Deployment is done using platforms like GitHub Pages, Netlify, etc. This makes the site publicly accessible. The final result is a clean and professional homepage. It includes well structured content, consistent design, responsive layout, and so much more. This project demonstrates strong front end skills, understanding real world workflows, and a production based web page. Overall, it reflects a solid implementation of web systems engineering concepts. In conclusion, this project shows that web systems engineering is not just about writing code. It involves planning, design, architecture, and best practices. By combining all these elements, we can build systems that are efficient, scalable, and user friendly. Thank you for your time. I hope this presentation gave you a clear understanding of the project.